Good day everyone, you are welcome back to mathematics class. Today we want to look at practical applications under trigonometry that we have been looking at. And the first question we are going to be taking says, if sine p is equal to 3 over 5 and p is an acute angle, what is the value of tan p? This is also a WAEC question. Now let's solve this together. Solution. So I'm going to make a sketch of an acute angle, then I'll label it accordingly using sine p given to us. Okay, so this is a typical acute angle, that is angle less than 90 degrees. Okay, so let me just complete it like this. So I'm giving sine p is equal to 3 over 5, and you know that sine means the formula for sine is opposite over hypotenuse. So if this is my angle p, so meaning that the opposite is this side, which is 3, okay, and then the hypotenuse will be this side, which is 5. Understood? So that is that about that. But I still need to know the value of this third length here. So what I'm going to use to get that third length is Pythagoras theorem, because I'm told to find the value of p. Alright, so you will recall that Pythagoras theorem says hypotenuse squared is equal to opposite squared plus adjacent squared. So my hypotenuse in this question is 5. Okay, 5 squared equal to, here the opposite is 3 squared, then plus the adjacent squared. So here 5 squared is 25, plus equal to 3 squared is 9 plus the adjacent squared. Alright, so 25 minus 9 will be equal to adjacent squared. So I can say adjacent squared is equal to 25 minus 9 will give us 16. Alright, so take the square root of 16. That will give us the adjacent. So adjacent will be equal to square root of 16. So what is the square root of 16? The square root of 16 is equal to 4, because 4 multiplied by 4 will give us 16. Now that we know that the adjacent here is equal to 4, then I can go ahead and find tan p. So therefore tan p will be equal to opposite over adjacent. So that's the formula to find the tan p. Our opposite is 3 and the adjacent is equal to 4. So that is the value of tan p, and that is how to solve this type of question anytime you come across it. Let's look at another example so that you will understand it better. So this example says, given that tan x is equal to 5 over 12, what is the value of sine x plus cos x? It's also a WAEC question. Now let's quickly solve it together again. Alright, so let me make a sketch here as well, and I'm going to use tan x given to me. Alright, so I have this. Okay. Alright, so now the tan x I'm given says we have, let me write it here, tan x is equal to 5 over 12. And if my x is here, my angle x is here, then tan is opposite over adjacent. So where this angle x is facing will be my opposite, which is 5, and this side that the angle is using to sit down will be the adjacent, which is 12. So I'm left with this hypotenuse now. Okay, so before I can find sine x and cos x, I have to know what is my hypotenuse. So I'm going to do that using Pythagoras theorem to find the value of the length hypotenuse. Okay, so hypotenuse squared is equal to opposite squared plus the adjacent squared. That is Pythagoras theorem. So hypotenuse is what I'm looking for. Then equal to the opposite is 5 squared plus adjacent, which is 12 all squared. Understood? So hypotenuse squared will be equal to 5 squared is 25 plus 12 squared is 144. So when you add these two numbers together, you will have 169. Okay? So therefore my hypotenuse will be equal to the square root of 169. And what is the square root of 169? Yes, the square root of 169 is 13. All right. So this hypotenuse on this figure is 13. Now that I know the three sides of this triangle, I can go ahead and find sine x. Sine x will be equal to opposite over hypotenuse. What is my opposite? Sine x. So what is my opposite? The opposite is 5 divided by what is my hypotenuse? 13. So sine x is equal to 5 over 13. Now let's go ahead and find cos x. Cos s is equal to adjacent over hypotenuse. Then what is my adjacent? Adjacent is 12 divided by the hypotenuse, which is 13. So cos x now is given to be 12 over 13. Now let's go ahead and find the value of sine x plus cos x. So sine x plus cos x will be equal to, what is sine x? Sine x is calculated to be 5 over 13 plus cos x is calculated to be 12 over 13. Alright, so this is addition of fractions with common denominator. So I will only add the numerators together, which is 5 plus 12, then divided by 13. Alright, so 5 plus 12 will give us 17 divided by 13. So, and this is the value of sine x plus cos x. Understood? So this is how to solve this type of question. Now let's take a look at another question. The question says, from a place 400 meter north of x, a student walks eastwards to a place y, which is 800 meter from x. What is the bearing of x from y? So this is another WAEC question that we are taking. Solution. So this is a practical question under trigonometry, and this question itself is a bearing question. Understood? Now we are going to sketch out this question before we try to find the bearing of x from y. Okay, so the question says, from a place 400 meter north of x. So I'm going to first of all begin. Let me first of all start by sketching out a 4 cardinal points here. Okay, so here now we are having north, we are having south, we are having east, and then we are having west. Is that understood? So that is the whole essence of me writing this 4 cardinal points here. So let me take the letters. Now from a place 400 meter north of x. So this is where the point x is actually. Understood? So a student walks eastwards to a place y. But before that, let's move 400 meter north of x first. So I will start from north here and move until I reach 400 meters. So let's assume this is where my 400 meter terminates. I will still draw a 4 cardinal at this point, okay, because the journey is not yet over. So this is my 400 meters. Okay, so a student walks eastwards to a place Y. So you see, this is my east. All right, so I'm going to move in that direction now. So a move eastward to a place Y. So I'm going to move and move and move until I got to a point Y. Okay, so this is point Y. Understood? So, and which is 800 meter from X. So this point Y now is 800 meters from X, meaning that from this point, if I join it to this point, oh, sorry for this line, it's not straight, but this is what it is actually. Okay. So, and they said this line is 800 meters. Now, what is the bearing of X from Y? Now, let me quickly show you what we are going to do in order to get the bearing of X from Y. So this is point Y, and we always start the bearing from the north. No, this is north. So you are going to move from here. So if you move down from here to this point, that is 180 degrees. Then if you move again, then you are going to touch the line that leads to point X. So at this point, you are going to get the bearing of X. All right. So I already know that from this north pole to this south pole now is 180 degrees. So I needed to know this angle now. Once I know this angle, I will just add it to 180 degrees, and that will give me the bearing of X from Y. But the question is, how do I get that? So there is no cause for alarm. Just follow step by step. You will get that very soon. Now, let's assume the angle here is theta. Okay. Now, and I go ahead and find cos theta. Cos theta is adjacent over hypotenuse. Understood? Now, what is my adjacent? My adjacent here is this 400 meters. Okay, I'm going to put it 400, then divided by hypotenuse. The hypotenuse here is the longest side, which is 800 meters. So my cos theta now will be equal to this zero will cancel these zeros. Then 4 in 4, that's 1. 4 in 8, that was 2. So I have 1 over 2 left, which you can also be you can also write as cos theta is equal to 0.5. Meanwhile, what we are trying to look for now is the theta itself. So I'm going to write theta is equal to arc cos 0.5. Okay, so the inverse of cos will give me the value of theta. So my theta will be equal to, if you press your calculator, arc cos 0.5 will give you 60 degrees. Is that understood? Okay, so it means this theta here in this diagram is 60 degrees. Now, if you come here, this angle, okay, this angle here that I was referring to the other time will also be equal to 60 degrees. Why? Because it's an alternate angle. All right, because this is a straight line and is parallel to this side also. Okay, then we have a transversal line. Understood? Now, that is why we got this place to be 60 degrees, alternate angle. In that case, I can conclude and say the bearing of X from Y is equal to 180 degrees, like I said earlier on, from this north pole to this south pole here is 180 degree. Then that 180 plus this calculated 60 degrees now will give me the bearing of X from Y. Okay, and 180 plus 60 degrees will give me 240 degrees. So that is the bearing of X from Y. Understood? Okay, so let's take a look at another question. The question says, a motorist starts from O and moves in a direction of 30 degrees for 36 kilometers. it then moves 7 kilometers towards the west. How far east is E now from O? So it's also a WAEC question. So let's solve this together. Solution. Now let's quickly sketch this question also before we try and solve it. Okay, so a motorist starts from point O. So let's take our point here. So this is our point O, and motorists move in a direction of 30 degrees for 36 kilometers. So if I start my bearing from this north, you see this north, this is north. Okay, that's where you start your journey from. So let's assume the motorists move and cover this is at 30 degrees. Then I will move this way in that direction. Okay, so the angle here is 30 degrees. Okay, so and it got to this point, and the total distance covered is 36 kilometer. Okay, then at this one, let me make a point here. Okay, so it then moves 7 kilometer towards the west. Okay, so this is the west, this side is the west, so I'm going to move in that direction now for 7 kilometer. So I move, so this is 7 kilometer, so I'm going to write it 7 kilometer towards the west. Then how far east is E now from O? How far east? So meaning that from this point O and towards the east of point O, this is the east. Okay, so when you move from this point O now towards this east to this point, then you trace it down. So this where it is. So what is the distance between this place and this place? That is what they actually ask us to calculate. But in order to make things easy for us, permit me to sketch this again from here. So I want to complete this triangle. Okay, so let me complete it with dotted line this way. Okay, so let me take this letter that I wrote here so that I will have a clean diagram. All right, so now I have a triangle, a complete triangle. But this is the point where the motorist is now at this particular point. So the distance I want to calculate now is from this point to this point. So once I know that length, then that will be the answer that's needed for this question. Okay, so now let's tag this place y, this length, let's call it y. Understood? So I'm going to call this place 30 degree because that is what we're given to be from the question. It's actually 30 degrees. Then I'm going to apply sine 30 on this triangle because sine 30 will capture this opposite, which is y and 7 kilometer, and the hypotenuse. So sine 30 will be equal to opposites over hypotenuse. Then sine 30 degree will be equal to, my opposite is y plus 7. Okay, that's the total length of the opposite, then divided by the hypotenuse, which is 36 kilometer. Okay, so when you cross multiply, you will get y plus 7 is equal to 36 multiplied by sine 30 degrees. All right, so y plus 7 is equal to 36 times sine 30. In the special angles we did earlier on, sine 30 is 0.5, or you write 1/2. Okay, so y plus 7 is equal to 2 goes into 1 time, 2 goes in 36, that is 18. So we have y plus 7 is equal to 18. When you collect the like times, you have y to be equal to 18 minus 7. So y is equal to 18 minus 7 will give us 11 kilometers. Okay, So that is the distance that the motorist is from O. All right, so let's take a look at another example. The question says, if tan theta is equal to 8 over 15, find the value of sin theta plus cos theta divided by cos theta open bracket 1 minus cos theta. Okay, so let's solve this together. Solution. So we are given that tan theta is equal to 8 over 15. And you know that this 8 is equal to the opposite, okay, and this 15 is the adjacent, because tan theta is opposite over adjacent, so you have to take note of that. So let me quickly sketch a diagram in order to find the third side of this triangle. Then we'll be able to find sin theta, cos theta, and compute the value of the fraction given to us. Okay, so I have this triangle. Now, using this tan theta, if actually my theta is here, then the opposite will be 8, the adjacent will be 15. Okay, using Pythagoras on this triangle, we are going to get our hypotenuse. So hypotenuse squared will be equal to the opposite squared plus the adjacent squared. So hypotenuse squared is equal to 8 squared plus the adjacent, which is 15 squared. So hypotenuse squared is 8 squared will give us 64, plus 15 squared is 225. And we continue, we get our hypotenuse to be equal to the square root of 64 plus 225, that will be 289. And the square root of 289 will be 17. So the hypotenuse here now is what? 17. All right. So from this diagram now, you will all agree with me that sin theta now will be equal to opposite over hypotenuse, which is 8 over 17, and also cos theta will be equal to adjacent over hypotenuse, which is 15 divided by 17. So now that we know the value of tan theta, cos theta, and sin theta, we can go ahead and find the value of sin theta plus cos theta, then divided by cos theta open bracket 1 minus cos theta. Okay, so let's quickly do that very fast, and the whole of this will be given as sin theta is 8 over 17 plus 15 over 17 divided by, then cos theta, which is 15 over 17 open bracket 1 minus cos theta, which is 15 over 17. All right, so now we are going to solve it step by step. Let's solve the numerator first. So the numerator, 8 over 17 plus 15 divided by 17, will be equal to 8 plus 15 over 17. And that will be 8 plus 15 is 23 divided by 17. So that's the numerator. Then the denominator is 15 divided by 17, then 1 minus 15 divided by 17 will be equal to 15 divided by 17. Then let's solve these terms in the brackets. So that will be, the LCM will be 17. Then 17, how many 1 can you see in 17? That's 17. Then 17 times 1 will give us 17. Then minus, how many 17 can you see in 17? That's 1. 1 times 15 is 15. Okay, so everything divided by 15. Now if you solve this further, you have 15 divided by 17, then multiply by 17 minus 15 will give us 2 divided by 17. If you multiply this together, you are going to get 15 times 2 is 30, and then 17 times 17 is 289. Understood? Now that we have solved numerator and denominator separately, now what we needed to do now is to compute it together. So therefore, sine theta plus cos theta divided by cos theta open bracket 1 minus cos theta is equal to, the numerator now is 23 divided by 17, then divided by the numerator, I will write it as divided by 30 over 289. Okay, so that will give us, let's change this division to multiplication. So we have 23 divided by 17 multiplied by 289 over 30. So it changes like this because we have changed the division to multiplication. Alright, so 17 goes in 17 one time, 17 goes in 289, that is 17. Alright, so at the numerator we are having 23 times 17 left. 23 times 17 will give us 391 divided by, at the denominator we are having 30 left. Alright, so this is equal to, how many 30 can you see in 391? If you do it very well, you get 13 remainder 1. So 13 whole number 1 over 30. So, and that is the final answer to this question. Alright, so lastly, let's take a look at another question. So this question is lengthy, but we are going to take it. The question says a ladder AB, which is set up with B on the horizontal ground and A against a vertical wall, makes an angle of 71 degrees with the ground. It is prevented from slipping by a tight rope PQ of length 1.68 meters, fixed at P to the foot of the wall and at Q to the ladder PQ being at right angles to line AB. Calculate in centimeters. A, the height AP of the ladder above P, and B, the length of the ladder. So this is also a WAEC question. Solution. Alright, so they said a ladder AB is set up with B on the horizontal ground and A against a vertical wall, makes an angle of 71 degrees. So let's assume that our wall is this. Okay, this is the wall. Alright, so, and then this wall now has its foot. So the foot of this wall is on the ground, and then the ladder also will be put on the ground. So the ladder is laid vertically against the wall, okay, while the point A is touching the wall, and then the second leg of the ladder is on the ground. Okay, so I'm going to draw the ladder this way. Alright, so this is my ladder and it's touching the ground, so I will join it like this. So this is the ground. Alright, so this is the ground that the ladder is touching. So my ladder is AB, and then the wall is AP. Understood? So let's read further. And they said it makes an angle of 71 degrees with the ground. So that is, this point now is 71 degrees. Is that understood? So they now say it is prevented from slipping by a tight rope PQ of length 1.68 meters, fixed at P to the foot of the wall at point Q. So let's say this is that point Q, then the rope is tied to point P to point Q. So this is point Q. Okay. Alright, so that's the, and the length is 1.68 meters. So 1.68 meters. Understood? So let's read further. Then PQ being at right angles to line AB. Okay, so this is right angle. Understood. Then calculate in centimeter the height AP. So we want to calculate this line AP. Understood. And then we will also calculate the length of the ladder, which is line AB. All right. Okay, so from this point A, if I make a sketch like this, if I make a line parallel to the ground, okay, then we are going to have a transversal line, and the transversal line is line AB. Okay, so this angle here is 71 degree. Then this point also will be 71 degrees. That is alternate angle. Understood? Okay, so another thing that I would like you to note is the whole of the angle here, this angle here, okay, is 90 degrees. Okay, 90 degrees, but this part now we already said is 71 degrees. Now if I want to know this angle inside here, I'm going to take away 71 from 90, and once I do that, I will get the angle inside. Okay, so what I'm saying is that angle PAQ, that is this angle here, understood, is equal to 90 degrees minus 71 degrees. Okay, so angle PAQ will be equal to 90 minus 71 will give us 19 degrees. Okay, it's not 190, 19 degrees. Okay, so meaning that the angle here now is 19. All right, so we now have a triangle APQ that we can work with now in order to get our line AP, which is the height that they ask us to calculate in point A in meters. Understood? So let's continue at the next page. Okay, so now we want to answer question A. For us to answer question A, I'm going to bring this diagram that I sketched earlier on at this point so that we all see. Permit me to quickly redraw the diagram here. I have resketched the diagram here. Now I'm going to use sine theta on this angle, this triangle APQ. Okay, but before that, let me convert this 1.68 meter given to me in centimeters, because the question says we should calculate in centimeter. So 1.68 meters will be 168 centimeters. So just multiply 1.68 meters by 100, and that will convert it to centimeter. Now let's use sine theta, which is sine 19 degrees. Okay, so sine is equal to opposite over hypotenuse. My opposite here is 168, then divided by hypotenuse now is side AP that I am told to find. All right, so when you make this AP the subject of formula, so you have AP, this side AP, to be equal to 168 divided by sine 19 degrees. Okay, so let's continue. AP now will be equal to 168 divided by sine 19 degrees is 0.3255. all right, so when you divide this, you are going to get your side AP to be equal to 516.1290 centimeters. All right, so but to the nearest centimeter, you will just get 516 centimeter. So that is the height of the ladder above P in centimeters. Okay, then B, they ask us to find the length of the ladder. So the length of the ladder is this line AB in this diagram. So for me to get that now, I'm going to use sine 17 in order to find it. Is that okay? So because sine theta, but now the theta is 71 degrees. So sine 71 is equal to opposite, and my opposite is side AP divided by hypotenuse, And what is my hypotenuse? The hypotenuse is the length of the ladder, which is AB, that I am told to find. Understood? So now let's plug in the parameters. Line AP is 516 centimeter divided by side AB that I am told to find. Then making side AB the subject of formula, I will have it to be 516 divided by sine 71. So side AB, which is the length of the ladder, will be equal to 516 divided by sine 71 is 0.9455. Understood? So, and let's continue here. Then AB will be equal to 516 divided by 0.9455 will give you 545.7430 centimeters. Well, so to the nearest centimeter, you have line AB to be equal to 546 centimeter. So that is to the nearest whole number or nearest centimeter. Is that okay? So, and this side AB is the length of the ladder we were told to find. Understood? Alright, so this is where we are going to be ending the class for today. See you in our next class. Bye.